First tip here to isolate the base raised to an exponent and rewrite as a log, that's what you just practiced in the warm-up. If you can look at your equation and your variable is up in an exponent, but there's only one exponent in the whole equation, get that exponent and its base all alone, and then use the inverse property, rewrite it as a log, and you'll be able to solve. So this step is really the thing you learned already in Algebra 2. So everybody walking into this room, we're coming from at least Algebra 2. We already know how to solve equations that have exponents or variables in the exponent. We have to use the inverse operation, which is the log. Okay, some of us need more practice with that than others. Okay? Just as a review, you know that. That's also what you saw in your warm-up problem. Okay? Now, some equations can't be solved by isolating the base to the exponent, and usually in those equations, the reasons why we can't solve by isolating is because we have more than one variable exponent in the problem. So here are some options for you to look at, like when you get stumped and you're like, this problem doesn't look like my other problems. I don't know what to do. Try your one-to-one property. You've studied one-to-one property or you did problems like this in Algebra 2, but we maybe don't necessarily name it one-to-one. If you want to review, your one-to-one property is in your section 3.1, and I can write that one out really quickly. If a to the x equals a to the y, then it must be true that x equals y. That's the only way that would work. So I have an example over here on the sideboard. 2 to the x plus 3 equals 4 to the x. This would be a great example of like, I can't isolate the base and its exponent because there are two of them and rewrite it as a log. So I could just use my one-to-one property and rewrite 4 so that it was base 2 squared. The important thing on a problem like this, and some of you will get feedback on this from your quiz on Thursday, don't rewrite 2 as 2 squared. Because then you've changed the whole problem. You've changed it to be 4 to the x plus 3 equals 4 to the x, and that's not what it is. You want to rewrite the 4 as 2 squared so that it still reads the same, but now they have the same base. So you have to be really careful with that one. Okay, sometimes one-to-one property won't work because you can't get like a base raised to an exponent on each side. There's some other term at play. So in those cases, you might try to factor. And we'll do an example with a factor problem as well. But you might try to factor. And that's just kind of like something you got to get used to. I will give you a hint here on factoring. Generally, I try to factor when it looks like a trinomial. So when I say trinomial, I mean what? How do things look like trinomials? They have 3 terms, right? So there's probably like 2 terms that are bases raised to exponent, and then there's some other term in there that doesn't match up. So I'm going to try to factor it. Okay, and then the last one, this one's new, so make sure you get this one in your notes. We'll do one like this. What if you don't have to factor it, but you have a base raised to exponent on both sides, but you can't rewrite either or both of them and have the same base? Then what are you supposed to do? That might have been a question you asked your Algebra 2 teacher last year. Well, what am I supposed to do if I can't rewrite it? And in Algebra 2, we're like, oh, don't worry, we'll give you one that rewrites. Okay. My example over here on the sideboard, I changed it to 2 to the x plus 3 equals 3 to the x. If you look at powers of 2 and you look at the list for powers of 3, they're never the same. All the powers of 2 are even, all the powers of 3 end up being odds. And so you can't rewrite both of them to be same base because they don't share any factor in common. 2 and 3 are primes. They've got nothing in common, so there's no way to rewrite them with the one-to-one property. So in that case, I would use this, which is take the natural log of both sides and then use your properties of logs. Okay, so that's tips for exponential equations. Here are some tips for log equations. This first one, again, this is really, I expect everybody coming in here, you know, some group said, well, will you give us a hint as to how to solve? I think it's filed back there, way back in that last drawer that you hardly ever open until you get to exponentials and logs, right? But you do have that knowledge that if you have a log in your equation and the variable is behind the log, you need to isolate that log, get it all by itself, and then, of course, use the inverse property, which is rewriting it in exponential form. And that will help you solve. Now, there are some other cases where you might have more than one log in the equation. So options, of course, I've got the one-to-one property right there. And that's from section 3.2. So the one-to-one property says if I have the log base a of x equal to the log base a of y, then x must equal y. And the other one is try using condensing properties. So as long as the logs have the same base, if you have two logs that are being added together, they'll condense into one log of a product. So you multiply the two things behind the log. If you have two logs that are being subtracted, you can condense them into two things that are being divided, okay, u over v. So if you use condensing property, then you go from having two logs to having one log, and that might help you solve. Whether you can then rewrite in an exponential form, or you can use a one-to-one property. Okay, condensing might make that a little bit easier. Okay, now I have one final thing for you to write down before we get into some examples. And that is, for a log equation, you must always check your answers, not necessarily for accuracy, although you can, like I did in the warm-up, but to see if you have something called an extraneous solution. And I usually just abbreviate that EXT when I see it. And extraneous solutions show up in the different functions that we solve that have restrictions to their domains. So if there's some x that you can't put into the function, you have to double check your solution and make sure that that's not causing a problem. So I said back in section 3.2, you can't take logs of negatives and you can't take logs of 0. There's no exponent that's going to turn something negative, and there's no exponent that turns something into a 0. That's why we have the horizontal asymptote at y equals 0 for the exponential function. Can anybody describe extraneous in their own words? Maybe your algebra 2 teacher had you talk about it or described it. What does it mean, extraneous? Like, how is extraneous different than a wrong answer? Okay. If you plug it in, there's something about the equation that won't let you complete it, sure. And does it mean that any of your math was bad? No, your math is perfect. You got the right answer. You are right on. So it's not like you have a wrong answer, you just have an answer that doesn't work. I often use the phrase for extraneous, I call it a false solution. You've done everything right. So it is the right x value, except the function won't allow that to work. Side note on my second bullet point, x can be 0 and x can be negative. So you can have those answers. It's just that you have to check when you plug them back into your function if there's a log in it, that they don't make the thing behind the log 0 or negative. Like sometimes you might plug it in and it'll still be positive and you'll be okay. Okay, so now let's do some examples. I'm going to start with this one. I'd put these 3 examples that I do in my notes because these are the hardest examples. that people have the most trouble with in Chapter 3. So I'm going to do one of each of the hard ones. Oh, I would say hard, maybe different, new. Okay, I've got e to the 2x minus 3e to the x plus 2 equals 0. So if I look at my e to the 2x and my minus 3e to the x, those are not like terms. E to the 2x is not a like term with e to the x, so I can't combine those in any way. And then I might think about like trying a one-to-one property, but the problem here is I have this pesky plus 2. That it's always going to be on one side of my equation, and I'm never really going to have it a base to an exponent equals another base to an exponent. So this is a signal to me when I have 3 different terms that can't be combined in any way, and I can't use the one-to-one property. I'm going to try to factor. Yeah. So in a trinomial, you normally have 2 binomials. And this is like our first go round, so this might feel a little bit weird at first, but we're going to stop and think about e to the 2x. What could multiply together as first terms to give you e to the 2x? E to the x and e to the x. Okay, so think about that. If you did, like FOILed it out, e to the x times e to the x, when you multiply things with the same base, what do you do with their exponents? Add them, so that's x plus x, so wouldn't that be e to the 2x? What if it was e to the 4x? What do you suppose multiplied together? E to the 2x and e to the 2x. Now, could it technically be e to the 3x and e to the 1x? Yeah, but if your middle term is e to the 2x, you need them to be the same, right? So you can kind of tell what that first term is going to be. If you're not sure, write down what you think it could be and then multiply it and see if it actually works out by properties of exponents. Okay, once you figure out the first term, the rest of it's not too bad. Do you have factors of 2 that add to make negative 3? Negative 1 and negative 2. So that if I FOIL this out, e to the x times e to the x is e to the 2x. I would get negative 2 e to the x, negative 1 e to the x, so there's my negative 3 e to the x in the middle term. And negative 1 times negative 2 is plus 2. So I've checked it. It works. Okay, so that's factored. How do you solve by factoring? What's the next step after you factor? Set them equal to 0. Yep. Don't overthink it. Set your factors equal to 0. So these are going to be really easy exponential equations for you to solve. E to the x minus 1 equals 0, and e to the x minus 2 equals 0. Add 1. Rewrite it in log form because now the variable is trapped in the exponent. So this is a natural log of 1 equals x. Well, I could also have just thought about that in exponential form. What does the exponent have to be for it to equal 1? 0. So x equals 0. And then solve this one, e to the x equals 2. Since it is base e, I'm going to do the natural log of 2 equals x. I know that the x is going on the other side because that's the exponent, right? The answer to the log is the exponent. And then that's when I just have to type into my calculator. I think is that 1.693? That's right. Now, if you were curious about the accuracy of your answer, if you had a little extra time on a quiz or a test, you would take those values and plug them back in and see if they work out. Okay, but they should. Okay, and I don't have to worry about extraneous solutions on this one because the problem is not logarithmic in the beginning, right? It's exponential. Okay, so that's an example of factoring, and remember, it looks like a trinomial. That's kind of a clue of when you should try to factor it. Okay. All right, here's one where we're going to use that new method. Okay, so make sure you get this one down in the notes. And you might, when you're taking notes, you might like jot down off in the margins, like what are you doing for each step? If you sometimes have that moment where you go back and you look at your notes and they're totally unhelpful, you need to be writing more stuff down. Okay, little notes to yourself that you understand. Okay, so normally I would approach this problem, I would see it, and I would try to rewrite one or both sides so that they had the same base. But 3 and 7 are both prime numbers. They share no factors in common. And if you look at the powers of 3 and the powers of 7, you can't rewrite either one or both of them to equal the same number. So our note said, in the case when you can't use one-to-one property, take the natural log of both sides. So as long as I do it to both sides, I'm okay, right? Natural log. So this is going to be natural log of 3 to the x equals the natural log of 7 to the x minus 1. So I'm taking the natural log of both sides. Okay, then if you go back and you look at that bullet point, it says take the natural log of both sides and use the properties of logs. So which property of log are we using? Product, quotient, power. We're using the power property. We see 3 to the x and 7 to the x minus 1. So we're going to use the power property of logs to drop those exponents in front of the logs. Power property of logs. So that x is going to become x times natural log 3. And this I'm going to protect this one with parentheses, x minus 1 natural log 7. Okay. Now, mathematicians like their answers to be as exact as possible. So I'm not going to evaluate my logs right now, because if I do, I know I'm rounding pretty severely, even if I go to the 1,000. So can we all agree that the natural log of 3 is just a number? And same with the natural log of 7. It is some value, 1 point something, right? So if you had a number outside of this group of parentheses, x minus 1, what would you normally do with that number outside of the parentheses? You would probably distribute it. So I'm going to distribute that number. That number happens to be natural log 7. And I'm going to leave it exact. Okay, so I'm going to multiply it by x, and I'm going to multiply it by negative 1. So on this line, I am distributing from the line above. I don't have to distribute anything on the left. I get x natural log 7 and minus natural log 7. So again, these natural logs are just numbers. So the natural log 3 is really the coefficient to my x on the left. And the natural log 7 is the coefficient to this x. And then when I have minus natural log 7 with no x, that's just a number, right? Okay, so reframe your brain here. What are you trying to do? Solve for x. So as you survey your equation, you notice that you have an x on the left and an x on the right. In order to solve for x, you would really like all your x's to be on the same side. Okay? So I would then get x on one side. And if you had other like numbers, you could say numbers on the other. But I can get x on one side if I just subtract a x natural log 7. This one, negative natural log 7, I won't move because it doesn't have an x. So this is x natural log 3 minus x natural log 7 equals negative natural log 7. And I'm not scared of these natural logs. They're just numbers, and I don't want to write the decimals, right? So I'm just treating them like numbers. Now, here's the nice thing. Once you get all your x's on one side and anything that doesn't have x on the other, if both of these terms have x in them, I can do what? I can combine them, but it's probably easiest, I think, in this case to say you're really factoring out an x, right? I mean, you are combining them. You're doing natural log 3 minus natural log 7, and that's times x, because they're like terms. So I say factor out x, because they both have an x, but it is combining like terms. You can also think about like the coefficients. I'm going to put up here factor out x, but if you want to describe it different, that's fine. Okay, that natural log 3 minus natural log 7, remember those are just decimals. Those are just things being subtracted, and decimal minus a decimal is another decimal. How are you going to solve for x now? divide by all that stuff, right? It's just x times this number, whatever that number happens to be. So I want to divide both sides by natural log 3 minus natural log 7. Negative natural log 7 over natural log 3 minus natural log 7. Okay, now the other thing to be careful of is when you're going to put this into your calculators, if you have any kind of operation down here in the denominator, addition, subtraction, multiplication, or if you have addition or subtraction up in your numerator, you're going to need parentheses. Okay, so protect your numerator and denominator operations with parentheses. So I'm going to do negative natural log 7. I'm going to close that, divide, and then I have to do the natural log 3 minus natural log 7. And make sure you're closing your parentheses for the natural logs. Notice I have protected my natural log 3 minus natural log 7 with a set of parentheses. 2.297 is my answer. If you want to check your answer, let's see, I have a hard time seeing the screen. I showed you the answer button, but there's also a store button. It's right above your on button. So if you want to store this answer, 2.296, hit store, and then you can choose like a place to put it. So I usually just put it in A. So it's stored in A. So if I wanted to check my answer, I could do 3 to the, and then I would do A. I stored that one. And that's 12.466. And then I could do 7 to the A. Oops. A minus 1, was it? Okay, so I got A minus 1. Same answer. And like I always like when I'm storing, I always store things back. Like if I just store it back in A, then it just rewrites the new A. You don't have to go through the whole alphabet if you don't want to. But store is also a nice function if you're going to keep reusing a value. Okay, so 2.297 is my answer. Any questions on that whole process? Again, I don't have to check that one for extraneous solutions because the original problem was exponential, but I did check it with using my store function just to see that I would have an accurate answer. So you can always do that if you want to see if you're right. Okay, we'll do one more, and then I will give you some time to actively participate with your groups. Okay, but this way everybody will have seen the 3 that give us the hardest time. That's a response I get a lot when I give you time for reflection is we do easy problems in class and then my homework is filled with hard ones. Today, I do the hard ones. The ones you maybe haven't seen before. Okay, natural log x plus natural log x plus 2 equals 1. Now, note this. This equation is now logarithmic. So at the end, I'm going to check for extraneous solutions. And if I could, I would try to isolate the log, but my trouble is I have more than 1 log. So I might try to use like the 1-to-1 property, where I have 1 log on the left and 1 log on the right. But I have that pesky 1, so that's not going to work for 1-to-1 property. So any ideas on what you guys might want to do first? Factoring, not so much. What else is on that bulleted list besides for logs? If it can't use 1-to-1, if you can't isolate the log, then try condensing. Do you have a property for condensing 2 logs that are being added together? Yeah, it condenses into 1 log where the values are being multiplied. So this is really the natural log of x times x plus 2, and that's equal to 1. Ooh, that makes it a lot better. Because now how many logs are in your equation? 1. And if you have one log all by itself, like isolated, then you can rewrite it, change its form. It's in log form, let's change it to exponential form. What's the base for that log? E. So we're saying e to the first equals, are you okay with me distributing over here? X squared plus 2x, that product. Remember, the answer to the log is the exponent, so it should be e to the first. Okay, normally if you have an equation with an x squared and an x in it, you need one side to be equal to 0 to solve, so I'm going to subtract my e, and I'll just write it as minus e. Now I could take my pick, you know, if I could factor that I would. Are you going to be able to factor if the last term is e? Nope. So what do you do if you can't factor? No! Quadratic formula! Okay, cool. So in the quadratic formula, a is equal to 1, b is equal to 2, and c is equal to e to the first when you use your calculator, right? I like to sing my quadratic formula song when I do the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're welcome. How many people love the quadratic formula song? Okay. Not a soul? How many people? Thank you, Randall. I knew someone here liked it. I had one person, third hour too. I'm not alone. Okay, now you just need to clean this up before you go to calculator. So this is negative 2 plus or minus. This is going to be 4, and it looks like, oh, this was a negative e, wasn't it? It would have been minus 4e, but I forgot my negative, so it's a plus 4e, isn't it? E is, oh, I didn't write a negative in front of it down there. That's why I did that. It's a negative e. It's supposed to be plus c. My apologies. So that's 4 plus 4e all over 2. Now again, most of this is, can you do it in your calculator? Okay. So you can take your pick of like how you want to do it. If you want to do it all at once in the calculator, remember you have to protect operations in numerators and denominators. So the plus and minus in the numerator needs to be in a set of parentheses. So I'm going to do that in my calculator. Let's see, that's a negative 2 in front. Negative 2 plus, oh, I forgot my parentheses for my numerator. I'm going to go back. Negative 2 plus the square root. This 4 plus 4e and for this one, when I do e, the calculator requires me to put in an exponent, so I'm going to say e to the first. And then I need to get out of the square root, and I need to close the parentheses. So that's my whole numerator, negative 2 plus the square root of 4 plus 4e. Make sure that's all underneath the radical. And then divide by 2a, which was just 2. So one answer is 0.928. And then if I do second enter or I scroll up, I can go right back to the thing I had before, and I just have to do the minus of that version. So negative 2 minus. And hit enter. So 0.928 and negative 2.928. Are my two answers. Those will be good problems for you on your homework, like so that you can practice plugging that into your calculator. Can you get the right answer? Remember, this was a log equation, so take each of those. Is it okay to put 0.928 after these logs? Yeah, I'll be taking logs of positive numbers, so that'll be fine. Is it okay to put negative 2.928 behind these logs? Not this first one, it's definitely going to be negative, so then it's definitely extraneous. Even in the second one, you're only adding 2, so then that's also a log of a negative number. So you would need to cross this off and label it extraneous. So your only good answer is 0.928. Could both of those work? Yeah, it just depends on what comes behind the log. Okay, if I added enough to make it positive, that would be fine. Could neither of these work? Sure, maybe they're both extraneous, and then you have no solution. Okay, so we've got just a little bit of time. We've got about 8 minutes. I'm going to give you and your pod a group of cards. These are dominoes, so like you can pick any problem and then work it out, and one of the other cards will have an answer that matches. Okay. So you and your group can kind of decide what you want to do with the next 8 minutes. Do you want to work together on a particular problem, like maybe you find one of the harder problems by looking at them, or do you want to each tackle your own problem? Then you can do that and see if you can find the matches. So you kind of decide. If you want some help, just say like, hey, can we do one together? Okay, so I'll give you some time to do those.